Hey folks, welcome back. In this video, I will be explaining about the AWS Application Load Balancer context-based path routing concept and its implementation using Terraform. So as you can see on the screen, this is the architecture which I am about to implement. What this is going to do is that the application load balancer will have its dedicated custom DNS in front of it, and once it receives the request, it routes the request accordingly. For example, if it receives something like apps.devops-in-cloud.com without any further extension, it's going to provide a fixed response. If it's going to receive a request something like apps.devops-in-cloud.com/app1, that request will be routed and load balanced across the A1 private EC2 instances across both the availability zones. Similarly, if it receives the request like apps.devops-in-cloud.com/app2, that request will be load balanced across the A2 EC2 instances across both the availability zones which are in the private subnet. So this is the functionality and the objective of this particular implementation. So how this is done? First, the main components of this architecture is going to be the application load balancer, the AWS certificate manager, and Route 53, the AWS Route 53. So we will be starting with the Route 53, and let me show you. In my account, I have already bought this custom domain to myself, which is akshaydevops.click. I didn't go for .com because .com is like $12 and .click was like $3, and I got it. So I have registered this domain in my AWS account, and which is there in my accounts Route 53, and I'll be using this particular host name as a front end DNS for the application load balancer. Let's check the code, and this is the code which we will be implementing. And okay, so I forgot to mention this particular application load balancer will have its dedicated security group, and this security group will have the port 80, port 443, which is the HTTP, HTTPS, and then the custom port 81, which is already enabled. And this particular security group, which is implemented in the security group module, that will be referenced in the application load balancer module. Yes, and that particular load balancer which will be referenced in the application load balancer resource, which I am going to explain. And then we will be creating the Route 53 data source. The reason we will be creating the data source is because we will be getting the zone ID of this particular Route 53 zone, which and in which we have already created our domain, which is akshaydevops.click. And this particular Route 53 domain will have its dedicated zone ID, and that will be taken from this particular resource. And for that, we have implemented the zone from here. So we'll be have gone to the documentation, data source, Route 53 zone, and I have taken it from here. So that is done. Next is going to be about the EC2 private instances. Until Bastion host, it's going to be the same, but in the private instances, what happens is that we will be importing two more. We'll be importing the same EC2 instance module to create both the private EC2 instances. And the thing is, in the private EC2 instance number 1, we will be installing the first shell script, which is right over here. And this will output application number 1, Akshay YouTube channel application number 1, and this and the second shell script is going to print out application number 2. That's how we will come to know how the path-based routing is actually working with respect to the load balancer. And for that, we will be executing 2 shell scripts across 2 different private EC2 instances. For private EC2 instance number 1, it's going to be app1.install, app1-install, and for private 2, EC2 instance is going to be app2 install.sh. That will be referenced over here. A1 is going to have app1, app1 is going to receive over here, and app2 is going to receive over here. And for these respective EC2 instances, these respective shell scripts will be implemented. Then we have the application load balancer resource, which is the main resource for this particular architecture. And this resource is taken from the documentation module right over here. So, I have taken the application load balancer module, I have implemented the module source and version right over here. Source and version is already implemented. I have taken the name, the load balancer type is application, not network, and then we are going to have the VPC ID, the subnets, and the security group. And the security, this is a security group which is referenced from here. So, this is security group which is assigned to the application load balancer resource. In this particular, let me show you. Okay, so in this particular application load balancer, since it's a context based path routing, first we will be implementing the HTTP to HTTPS redirect request. The redirect request works if the HTTP request is assigned, if the HTTP request is received, it will be redirected to the HTTPS. So, that is a redirect option, and that I have implemented in the action type as redirect, and the redirect to port 443, which is a HTTPS. And in order to support the HTTPS protocol, I have taken out the ACM, which is the certificate manager. Certificate manager secures the SSL and TLS requests, and that is done by creating a certificate and assigning to that particular DNS, and that is the reason the certificate is already created and referenced in this resource, in this load balancer. So, we have the HTTP TCP listener, in which the redirect request is already been defined. So, that is done. Now, we have the target groups, HTTP listeners, and the listener rules. Okay. So, the HTTP listeners, we are going to have the 443, and then once it reaches the DNS domain, the DNS URL, which is akshayadevops.click, it's going to give a fixed response, something like this, AWS application homepage. So, it's going to give a fixed response. If I give something like apps.akshayadevops.click /app1.index.html, that will be routed to, okay, so this is the request which we will be giving, the URL /app1, that is the first listener rules. If this is given, it will be indexing the target group index 0, and the first element is going to be this. So, right over here, that will be directed to the path is app1.index.html, and that will be routed to the private EC2 instance number 1, which we have defined over here. And in this particular private EC2 instance number 1, we will have the shell script, this shell script implemented. And likewise, if we have another rule, okay, what's this? Okay, so this is rule number HTTP listeners. Yeah, so this is the second rule right over here, and once this is implemented, it's going to with the path app2, it will be routed to the second target group index, which is this private EC2 instance number 2. Number 2, which is right over here. Yes, so that's the implementation which we will be achieving, and once that is done, we will be going to the Route 53 DNS, and over here we will be assigning our application load balancer DNS to the alias records of our custom domain, which is akshayadevops.click, with the alias as app1. So, in the alias we will be referencing the application load balancer DNS, its zone ID, and this zone ID again This entity will be referenced from the data source right over here, and then we will be creating the DNS records. So this was the entire implementation of the code, and after this we will be going with the Terraform lifecycle, which is Terraform init, validate, plan, apply with auto approve. So once we have those things in place, we will be going to the URL, which is apps dot akshay devops dot click. Let's go to the home page first. There we go. So now the application, the fixed response is working. So now, as per the architecture, okay, sorry about that. Okay, so let's open the architecture once again. We have app1 application.index and app2. So we will check those two as well. App1 index.html, app1. There we go. So app1 is working. Now let's check the app number 2. Yes, so application 2 is also working. So right now this architecture is getting implemented successfully. The app1 is getting routed to A1 instance, and app2 is getting routed to the A2 instance. But how do we check the load balancing of how do you check the load balancing between the A1 instances and the A2 instances? Let's see that. So if we go back to A1, we will have metadata.html. Okay, so that's gonna have, okay, now it's pointing to private IP with 2.165. Let's check our EC2 instances. Private app number 1, which is 2.165. okay, it is getting routed to this IP. Now let's refresh. Okay, now it is routing to 1.110. Let's check our EC2 instances, and we are going to have 1.110. Likewise, it's going to work for the private private app number 2 as well. You're going to check it out, and let me explain how the load balancer is actually working. So this is the application load balancer, which is already there, and that's the DNS. And that DNS will be recorded somewhere over here. Let me refresh it. Yes, so as you can see over here, apps.akshay-devops.click, that is created in the DNS records, and that has been assigned to route 53, and the alias is yes. So this is the DNS which we have. The same DNS is available over here, and this particular application load balancer will have two listeners with both HTTP and HTTPS, and in this particular load balancer has two target groups which are right over here, app1 and app2, and those two have the same load balancer, and that's how it is getting load balanced between the two EC2 instances across both the availability zones as per the URL request. Let's check that again. Index.html. So this is number 1, and let's check number 2 again. Done. So now add the application number 1, application number 2, and then let's give the fixed response as well. CK. Yes. So the fixed response application number 1 and application number 2. The fixed response application number 1 and application number 2. So we have successfully implemented the entire architecture of this of this Terraform implementation, and the entire code base is right over here. And I've attached my and I've updated this code in my GitHub repository. The link is in the description. Make sure you check it out. And in the next video, I will be explaining further concepts about AWS Application Load Balancer. Let's get started.